All right, question number 3A says the diagram below shows the triangle PQR in which angle QPR is 62 degrees, angle PQR is 90 degrees, and PR is 11 centimeters. So everything that they said to us, we could see for ourselves. We're asked to calculate the size of angle PRQ. So whenever 3 letters are used to reference an angle, the vertex of the angle is always at the letter in the middle. So if they're asking us to find angle PRQ, essentially what they're asking us to find is angle R. Don't overthink it. The 3 angles in a triangle must add up to 180 degrees. So angle PRQ would be equal to 180 minus 90 plus 62, which would be 180 minus 152. This angle here is 28 degrees. So this angle here, angle PRQ, is 28 degrees. Don't overthink the question, all right? And miss the simplicity in it. Next, we're asked to calculate the length of RQ. So we need RQ. All right, let's use trigs. As a matter of fact, we have to use trigs. All right, so to the 68 degrees, this side is opposite. Where the 11 is the hypotenuse. Then I ask myself, which trig ratio includes opposite and hypotenuse? The answer for that is sine. So I'm going to say sine of 62 is equal to opposite x over the hypotenuse 11. Then I would say to myself, if I have one fraction is equal to one fraction, and I want to get rid of the fractions, I would cross multiply. So 1 times x is equal to 11 times the sine of 62. So x, which is RQ, is equal to RQ is 9.71 centimeters. RQ is 9.71 centimeters. All right, let's continue. That's it. Apparently. All right, so this part of the question now is transformation. It says the diagram below shows 3 triangles X, Y, and Z on a square grid. So what are we asked? We are asked to we're told that triangle X is mapped onto triangle Y by reflection. State the equation of the mirror line. All right, so triangle X is mapped onto triangle Y by reflection, and we're to state the equation of the mirror line. I think that's what they said. State the equation of the mirror line. All right, now, first of all, in a reflection, the object and the image are the same distance from the mirror line. In other words, the mirror line is in the dead middle between the object and the image. So X is the object, Y is the image. All right, and the line that is in the dead middle between them is the x-axis. That's the x-axis. And we're asked to state the equation of the x-axis. The equation of the x-axis is y is equal to 0. So the mirror line is the x-axis, which is the line y is equal to 0. We're to describe the transformation which maps triangle X onto triangle Z. which transformation maps X onto Z. Now, looking at this, I can see clearly that it is a 90-degree rotation. Some of my telltale signs are the fact that this horizontal line here, that horizontal line there, is going to become this vertical line. Now, in a 90-degree rotation, horizontal lines are going to become what? Vertical. So since that bottom line there, which was horizontal, became vertical, I know that it's a horizontal rotation. I also know that the direction of the rotation is anti-clockwise. I know that the direction of the rotation is anti-clockwise. So that's two things. And the last thing I need is the center of rotation. In this case, the center of rotation is the origin. So I would say that X is mapped onto Z by an all right, please note that if you're describing a rotation, it has three components. You need to say the direction of the rotation. In this case, it's anti-clockwise. The angle of rotation, in this case, it's 90 degrees. And the center of rotation, in this case, which is the origin. All right. Now, if you miss out any one of those things, you're going to lose marks. The third thing says, we're on the diagram on page 10, we're to translate y using the vector -7, 1. Now, the translation vector -7, 1 is telling me how to move triangle y. The top value is talking about how I should move it horizontally. And the bottom value is telling me how I should move it what? Vertically. Now, the fact that the top value, which tells me how to move it vertically is, horizontally is negative, it means I must move the shape to the left. And the bottom value, 1 being positive, means I must move the shape up. So I'm going to, in order to do this translation now, I'm going to move y 7 units to the left and 1 unit up. So let's do that. So we're going to move y 7 units to the left. 1, 2, 3, 4, 5, 6, 7, and then 1 unit up. So that is going to be the new position of this tip here. 7 units to the left and 1 unit up. All right. The length of this, the length of that top piece is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Then like that. Then like that. All right. Now, another way you could do this, guys, you could move it 1 vertex at a time. So you move the first vertex, then the second vertex, and then the third vertex. And after you have moved all 3 vertices, then you use your ruler and draw the image shape. So remove this shape 7 units to the left and 1 unit up. Move the shape 7 units to the left and 1 unit up. All 3 vertices, move them 7 units to the left and 1 unit up. All right. Then now when we do that, it says that we need to call the new shape V. Lastly, it says that what on the diagram on page 10, we're to enlarge triangle X using the center, the origin as the center and the scale factor 1/2 and label the image W. All right, so we're going to label this image V. Then we're asked now to enlarge. We're asked to enlarge X using with a scale factor 1/2. Now, this is how I do an enlargement. Or this is how what I use to do an enlargement. The center of enlargement is the origin. Now, whatever is the distance from the center to a vertex, so there are 3 vertices. X has 3 vertices, 1, 2, 3. Now, whatever is this distance from the center to a vertex, to get the corresponding point in the image, I'm going to multiply that distance by k, which is the scale factor. In this case, k is a half, that is 1. Number 2, now, if the scale factor is more than 1, the image is going to be larger than the object. If the scale factor is less than 1, in this case a half, the image is going to be smaller than the object. Now, let's number the vertices just for it to be understood. 1, 2, 3. Now, from the center to vertex number 1, it's just what? 2 units up. From the center, which is the origin, to vertex number 1, it's 2 units up. To get the corresponding point on the image, I'm going to multiply that distance by a half. A half of 2 is 1. So the corresponding point for that vertex is this point. 1. Number 2, to get from the center to 2, I'd have to go 4 units to the right. 1, 2, 3, 4, and 1, 2, 3, 4 units up. 4 units to the right and 4 units up. Now, the scale factor is a half, so I'm going to multiply that distance by a half. 4 units to the right and 4 units up, multiply that by a half, I'm going to get 2 units to the right and 2 units up. So it's 1, 2 units to the right, 1, 2 units up. That's going to become the new position of 2. So this is going to be the new position of 2. From the center to 3, it's 6 units to the right, 2 units up. If you half that, you're going to go 3 units to the right, 1 unit up. This is the new position of 3. Once you have the position of all 3 vertices, you use your pencil and your ruler and connect all 3 vertices. Use your pencil and your ruler and connect all 3 vertices. So X is the object, and what we just draw, W, is the image. X is the object, and W is the image. And I believe that that is the end of this question.